those things. Um, Let me throw away this. All right. So, a lot of people is debating about first question. The answer is A. And I do see like it's kind of confused to think of like A, like it's really like vague. It's like abstract. So, when this morning I was doing it, I was messing up as well. If I try to think of in terms of A's, so I look at some kids' work that they actually just think about A is -2 to make their life easier because A is less than 0. All you gotta do is assume A is -2 or -3, doesn't matter. So what I would do is I would probably it's harder to think about like 1/A situation. I mean, some people can, but this morning I was out of it. And I'm still out of it right now. So I will probably what second period I have a kid named Alex Ballard, and then what he says is just assume A is a -2, and it would be a lot easier to think about rather than think about all this stuff. So if I have A is -2, so let's just assume that's -2x to the cube plus 3x squared plus 4x plus 5. Now, if you understand your way, it's fine. But I just thought like this is actually interesting with problem solving strategy. It could be anything because if A is less than 0, you could apply anything less than 0, right? So this is y prime that's equal to -6x cubed plus, -6x squared plus 6x plus 4. If you take another derivative, it's going to be -12x plus 6. And -12x plus 6 equal to 0, x equal to -1/2. So -1/2. Is that okay? And I'll just plug in 0. If I plug in 0, I'm going to get positive, and this is negative. So remember, this is -2. Sorry, this is actually 1/2. But this is 1/2. But it's due to because A is -1. A is -2. So therefore, this is the only answer that makes sense because if you do a number line test based on that. So I think the question is a lot easier by looking at, I was looking at people's work, and I think that his work is probably easiest to understand rather try to explain, try to fight you with abstract thinking. And it's really hard to think about those things. And my mind's still not working right now, so I can't even tell you a great explanation. So I think this is probably a good alternative to look at question solving is if they says if A is less than 0, you can just assume -2 and then you go from there. Might be easier to think about. Is that okay? Second question. Oh my god. F of 0 is equal to F prime 0 is equal to F double prime 0 is equal to 0. That sounds like very confusing things. But when they be must be true, all this question that said must be true question, first, it's usually only the best student can figure out. Well, actually, the people who get 4s and 5. The best student can figure out why they are wrong on its choices. So you cannot just say, I picked the right choice E, and that's my answer. But could you know why A, B, C, D are wrong? Why is A, B, C, D are wrong? Can you guys tell me that?
Okay. For A and B.
Separate. Oh, why don't you talk about you? Because you're yapping a lot.
I didn't talk.
You were obviously criticizing her.
Obviously, yeah.
So
Yeah.
what can you
So
tell
would
me?
you like to explain why it's 8 and why the others are wrong?
You want me to explain?
Yeah.
I just do process of elimination. I just look at every single one.
Okay, why are they wrong?
Okay, if it's a max,
So you're gonna get a 3 on IP exam.
bro.
Well, if you're lucky.
I said E.
Why?
Okay, that just proves that you can get a 3. But it doesn't prove you can get 4 or 5.
Yeah, watch. I'm gonna get a 6. Nice practice though.
So can you tell me what A, B, C, D are wrong? Why is that?
Okay, there's no max obviously, cause like.
What do you mean
if
by
it's a
obvious?
max- Huh?
What do you mean by obvious?
Well, if there's a max, it should equal to a number for the first derivative, second derivative.
You need to do a no line test check, right? But you can't, so you don't know.
No, it just has to be a number.
Well,
You take second derivative of something, what does it equal?
well, it's honestly no, but how do you know it's a max?
Well, that's a zero. That's the whole point.
Yeah, but like,
There is no max.
if you go to apply that.
So
So it's a zero, but you don't know if it's a max.
yeah, so the thing is about
Well, it doesn't matter if it's not.
no. That's what Lyndon would say was right. Is you need it based on number line tests. Because what if so think about it. What if you have second derivative, right? And you got 0 here and you got positive. So that means D is not true because that's just a possible inflection point. It's not really an inflection point. The same thing could be true for A and B because there's no number line test. It doesn't mean they're equal to 0, they're automatically maximum or they're automatic minimum. Or the automatic inflection point. Or extrema for that. So A, B, C say exactly the same thing. You can disprove by using a number line test. So what if you have F prime number line test, you get positive. If you have positive, are you gonna get a maximum here? Are you gonna get a minimum there? Are you gonna get an extrema there? So A, B, C is gone. And if you use the same logic, apply to number 2. So yeah, so you had to think about those things. Yeah, for you, it's intuitive, makes sense. Yeah, the truest is E, but you gotta be able to come up to a student. You had to say, okay, why is A wrong? Why is B wrong? Why is C wrong? Why is D wrong? You had to be able to tell them like why they doing, why is those things wrong, and that's what is probably a better way to think about those questions.
I say, but if the first and the second derivative equal the same thing, that means it's not like max. There's something else.
No, you could have had maximum.
When this first derivative, second derivative, and the whole every time it equals the same thing.
Well, yeah. So let's say this.
Yeah.
Is f0 equal to 0? Is f prime of x equal to 0? Okay. Is f double prime of x equal to 0? No. Okay. So let's give you another situation. Right. So this is a f0, f prime of 0, f double prime of 0, all equal to 0. Right. So there's no minimum and there's no maximum. You're right. But the thing is you have to have a. You're right with that logic of if they are equal to the same thing, well, if they both equal to 0. But you cannot say. No, I guess you're right in terms of the perspective. If they both equal to 0, they cannot be maximum min and the things. But I see what you're saying. But the things I'm probably trying to go to is everything is based on number line understanding rather than things. Yeah, but I think that is true by not with the proof, but with the deductive reasoning.
It won't prove.
Okay. We'll give you that for this time. We're gonna see next question. Okay, number 3, C. That just work. But you have to do number line test again. If you don't do number line tests, I'm trying to say to you, is f double prime of x is equal to 0. That doesn't mean that they are inflection point, because there's no inflection point at 0. You have to do a number line test. The key thing I'm trying to get to you is you have to have a number line test to prove that they are maximum or inflection point. And sometimes the true, like is a rhombus happen to be a square? Yes, sometimes, but it's not always true. May not be true. So you have to be careful with those situations. Okay, so 3 is that. This is a good question. And the reason why that's a good question is a lot of people are confusing. How many of you guys confusing about this one? Okay, so let's redo this one. Okay, to be able to pick the right answer is not a big deal. I think a lot of you guys can pick the right answer because you have good intuition, but doesn't mean anything. So, imagine that there is local maximum. So there's a C right here, and f prime of x. If you do f prime of x here, this is f prime of x. We're looking at slope. We're looking at f double. If I want to say inflection point, I must look at double prime. If double prime means what? F double prime of x is equal to slope of f prime of x. Does that make sense? Because slope means take a derivative, right? So if you take a derivative of that, then you look at the slope. What is slope at this point? What is slope at this point? Positive, right? So this is a positive because we just see the function is going up. The function is going down, this is negative. So understand that f double prime of x equal to slope of f prime of x. Very, very important. So this one has to be a inflection point. Second situation, if f prime of x has local minimum at f prime of x, that's also inflection point because you also have a sign change. Now again, f double prime of c is equal to 0 does not mean the inflection point because you could have sign not changing. So this one, again, same logic to exclude it. F double prime does not exist, same thing. Does not exist is still a possible inflection point, but it doesn't mean it's an inflection point. It just says possible, and that's the number line proof. The sign of f prime x change x equal to c. What does this mean? What does d mean? Can you tell me what d mean? Yeah, but what does that mean on f of x? Local what?
Local max, local min.
Local max and local min, right? So this is a local max and min. So you can tell that this is what the statement is talking about, because it becomes 5 different questions if you understand why those statements are wrong. E is not a choice because cubic function polynomial c equal to 0, that only can happen if x cubed or x cubed plus 1. Anything x cubed without any other terms. That's x cubed plus 3. Yeah, it would be a inflection point at c. But c equal to 0, that's really rarely to happen. Normally, that doesn't have to be at 0. Are we okay?
Wait, can you explain the difference between A and D? Like why the local min? Local min were.
Yeah, because this one is local max of f prime. So this part is a positive slope, negative slope, because you can look in order to find a inflection point, it's going to be double prime of x, and slope of f prime has changed sign. But this one is only talk about this. This is situations like this, f prime of x. It looks like this because it's changing from negative to positive. But that means the original function is going to be a minimum in this particular case. It doesn't mean anything else. It doesn't mean anything about inflection points.
Yeah.
Are you sure?
Yeah, I understand why, because it's changing signs. But
Yeah,
if
change sign is only changing from negative to positive. That just means it's changing to increasing or decreasing to increasing. That's a minimal. Mhm. Questions? This one I cannot come up with a good explanation, so I will not explain it because I don't want to explain something wrong. And if I explain something wrong, then that's bad. So I don't want to do this because my brain's not working today. And if somebody come up with a good explanation, it's good, but the answer is B only. Question 6. Question 6, I got D. 1 is really easy to proving false because if you look at this region here, is this region in particular is f double prime x is greater than 0, less than 0, sorry. Less than 0. But this region from -2 to 1, this is a false because this is f double prime of x is greater than 0. So therefore, 1 is not true because -2 to 1, this region is not true. This region is true. This is true. But this region is not true. Is that okay? Now, when I do this question, I do it really quickly on first period. I make mistake is by not looking at, there's one more word here, says vertical tangent at x equal to -1. And guess what? That's also a critical point there. That's a critical point here. That's a critical point here. That's a critical point. So derivative, the slope can be 0 or undefined. They're all critical points. Because definition of critical points, critical number is f double prime x has to be equal to 0 or undefined. So there are 4 points instead of 3. So this is the only one that's correct. So I make a mistake by first period. I didn't read that part. I'm still not 100%, but yeah. First period also helped me correct the first one too, because I make a mistake is I choose D. But the D is the wrong answer, by the way. Did anybody pick D? Nobody? You put D? D? Okay, so with a table like this, good, then you did better than me because I was not paying attention to details. If you pay attention to details, it seems like it went to positive, 0, negative, right? It seems like that is an inflection point. But Alden says, well, is it possible I can get like at 2 I got 6, at 4 I got 0, and at here it's -2. Is it possible I do this? It's possible. Because the problem is when they give you table values, that anything can happen between each values. So then you could possibly at here get -2, but at the other side it's got 6, and then you got 0. But you could have a bounce off and come back because they never told you what happened between. It could have this way too. It could have this way too. If you really think about it. So anything impossible between those values. The problem is table has a lot of fraud because the table can only tell you that certain value at a certain point, but it doesn't tell you anything else. What happened in between those 2 points, right? So can you bounce it off, hit it over? Can you go down and come back up here? Those are all the possibilities. If you don't exclude those possibilities, then that's wrong. So obviously, I choose D first and then mark around E. E is the correct answer because, hey, and obviously somebody paying more attention to me than me, so you would have got a right answer. So those are the cases that prove D is not true. How many of you guys pick E? Good. again, you need a number line test. I don't know what to say anymore. It's like you need a number line test. It doesn't mean x squared equal to 0 is inflection point. No, it's not, because if you do number line test, x squared has no difference at 0, at 4, at 7. That has no bearing of anything. This is all positive sign. X minus 4 is gonna be negative, negative, positive, positive. X minus 7 is gonna be negative, 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 positive. So it's positive, negative, positive, negative, positive. So you see that this sign does not change. So 4 and 7. Did anybody pick E? No? Good. What happened on the test? People just think about second derivative is equal to 0. For number 9, this is a velocity. Velocity, this is xt, but if you take a derivative, it's going to be velocity. So velocity is going to be positive and positive here. So if you take a derivative, you just look at the slope of that, which is this 2 points. Is that okay? Now, Perva here, calculator permitted. But I'd rather see you doing that. Winston also said the same thing. You take derivative again. Not necessary. You have calculator, use a calculator. There's a reason why they say calculator permitted. You gotta use a calculator. When you use a calculator, what are you gonna get? You're gonna get, what was the function? X squared? Sin x squared, right? Like this. And you're gonna be like, that's so much shit going on. I agree with you. I'm gonna restrict that between -2. And this is how you're gonna do it. And this is the graph. You guys see that? And what you can do is you can actually do this. Okay, let me ask you, when does the inflection point happen? Let's ask Fabian. When do you think an inflection point happened here?
Or next derivative of that.
You can find the inflection point from here.
Either from positive to negative.
So where do you think is inflection point?
Like guess the number.
Yeah, if you were to guess a number.
-1 and 1.
Why is it -1? Oh, I see. There's a concavity change there, but that's not what it is.
Then I'm not sure.
Apple, what do you think?
I was thinking the same thing. I saw like when it increases and then decreases.
Yeah, but that's not -1, right? It's -1.4. He was thinking about this point, which is, he's thinking about the inflection point of f prime. Do you see that? But that's not true. It's when the increasing, decreasing, it's those points. So local max and local min of f prime of x represents the inflection point of the thing. But if you want to confirm that, remember, this is a first derivative. You just take a second derivative, right? How do I take a second derivative? And I'm on a restriction here. Why so many things going? Oh, second derivative. I just need first derivative. Sorry. It's like this. Do you see like this point? This is second derivative. If I graph a second derivative, when we're changing from positive and negative, do you see this point and this point are the same? This point and this point. Sorry. This point and this point. Same value. Because it's increasing, decreasing, but if you look at second derivative, it went from positive to negative. It's okay? Everyone understand it? Fabian? Yeah. Look, this is the easiest part of the test because you don't need to do any math. You just have to think math. But this is also hardest part for a lot of students. I forgot his name. One of the kids I have, like he's horrendous in math, but when it comes to analyzing graph, he was on par. He was like, he understands where's everything. If you understand everything, like that kid, he's got a 4 on AP exam. He's horrible at math, but analyzing, he was really good. So you need us point to get a 5 also. So even you try to get a 5, but the answer is 3. Now this one's on AP exam, a multiple AP exam actually. And yeah, the answer choice is A, but do you know why it's A?
E, because you're the only one that was like exponential.
Yes, but no. So first of all, let's draw the situation. 4 is equal to 2. So at here, at 4, it's going to be around a positive slope. But it's concave down, right? So it's going to be like maybe something like this, right? So it's increasing faster and increasing slower. That's why they concave down. Increasing at a decreasing rate. Is that okay? Oh man, I have a headache. Okay. So you look at this. This is the difference is 2 and 2. So this is linear. Remember last year? The first difference, that's linear. Look at here, this is what? 1.5 and 2.5. Wait, that looks like increasing rate is concave up. So this one is concave up, this is linear. If it's assumed that they are connected directly. Is that okay? Now, everything else seems like it's concave down. But how do you know which one to pick? This is a difficult part. Anybody can come up with a reason? Yes, Liam?
When f prime 4 equals some.
Yeah, so what does that mean?
We need to look at the difference, like do the slope formula for each and see where 4 is 2.
Does that ever equal to 2? Does any time the slope is equal to 2? Huh?
Emily, no.
Emily? Yeah.
What did you say the average? Like you would obviously do the rate of change, like between I did it between 5 and 2.5, and then I did the one between 6.5 and 5 as well, and I added those together and divided by 2 because it's the average that we're trying to find, right? So if it's constantly down,
Well, the problem, it won't be average because you don't know what can happen between the graph. Yes, Max?
It's a rate of change to decreasing because it's concave down.
Yeah, so all of them is not going down though. Not a function there, A, B, C, not a choice is going down. But it did decreasing at a decreasing rate though, all 3 of them. So how do you know it's A rather than not B and not C? Yes?
This is because the rate of change is negative, so it should be growing smaller. The growth gets smaller.
Yeah, but the problem, all 3 have the same thing.
Oh,
It did grow at a slower rate.
B grows at slower.
Yeah. So it's 2.5 and 2. Yes?
Is it because the first derivative? Wait. Forget.
No. No balls.
No, I read it wrong.
Okay.
I was gonna say.
Oh, is it? For C. Yeah, that went up. But for C, it's like a linear decrease.
No.
It's
They still grow at decreasing rate.
What was your question when I
Like, how do I know is A, not B, and not C? Like, how do you know that that is? Oliver? Elaborate that. Did I say that? I see what you're saying. You were talking about mean value theorem. Okay.
It's concave down, so the channel line is going down. So the answer is A, because if you do 5 minus 2.5, the slope of the secant line is 2.5. So that means as you go, the channel line's gonna go down from 2.5.
You are like 99% right. It just need to like you just need to talk about you're 99% right because you talk about mean value theorem. But it's actually we wanted to establish a logic to it, right? So how do we know? It's actually very close to intermediate value theorem, if you really think about it. So he's right about looking at the slope of those. So slope of here is 2, slope of here is 1.5, right? Slope of here is what? 2.5 and then 2, right? And this is what? The slope of what? Do you see that this is the only one that go through 2? This one doesn't. You go 2.5 and with 2. This is 2, we go to 1.5. But there's only one that's going through 2. And this is the only one that's there. Does that make sense? But he's on the right track. So it's like you're driving average speed of 60 miles per hour. Sometimes you're gonna have to drive over 60, sometimes you're gonna have to drive below 60. And that's the idea of mean value theorem. Because as there must be a time you drive above, or there must be a time you drive below. But if I can say the speed here is 2.5, speed at 1.5, it has to go through 2. So does that thinking about intermediate value theorem rather than mean value theorem? Actually, mean value theorem is enough to explain it, but I think it has to go through 2. I think it kind of like taught me about intermediate. Does that make sense? Oh god, I need to sleep. 12? Nah, that's just a number line test. We already did that before. I like this one, 13. Anybody mess up 13? The answer is A. You mess up?
I got B.
Huh. So what I will do is I will take a derivative. Okay, but I will do 2 number lines, one overlay on another. One overlay on the other. So this is the first number line is plus, negative, plus, right? Between -1 and 2. Is that okay? Did you get that? If I take a derivative, I factor it. Now I take second derivative, but here's 1/2 here is right between 1 and 2. So this side is I think this side is, if I plug in 0, it's gonna be negative. This is positive. So the only one that is gonna be increasing and concave down, it has to be everything's less than -1, because in here there's a negative, there's a negative. So if you overlay on top of each other, it will be a lot easier to analyzing things. 14. I'm gonna do this one. How many of you guys got it wrong? Answer is A. You got it wrong? Good. I'm gonna explain how to do it. So I'll do a number line here. So the first number line is f prime of x, because this is f prime of x graph. We had only look at above or below x-axis. So this is above, write it down, or below x-axis. So I here is gonna give you positive. Is that okay? And here it's gonna be negative all the way through, and after that's positive. Is that okay? Is this number line test is okay? And just teach your kid and Dr. Philip, and she was confusing as heck. She was a straight A student. She was confusing, and with number line test, it helped her. I'm gonna look at f double prime of x. F double prime of x is looking for what? The slope of f prime of x. Is that okay? Because slope means derivative. Derivative of the f prime means double derivative. Is that okay? So if a slope here is negative all the way through, all the way to here. So I here is gonna give you a negative. I here is gonna be positive. From here to here, this is positive. From to here is negative, and everything is also good positive. Maybe there's 0, but it's still positive. So how many inflection point happen? 1. Right? It's actually occur at here. I think it's -6. You have to know which value is. -6, -1, and 1. So not only that I know it happened 3 times, I know where it happens. So anything with 4 and 2, that doesn't work. B, C, D is crossed out. A to the E, then you say, okay, how do I know how many maximum minimum? That's why you need to look at first derivative test. This one is a max. Do you see that? Because it crossed from positive to negative. And this part is minimum, so it's from negative to positive. So that is going to be a min. So that is not a E. A is only 1. But you have to do number line test. I'm going to tell you like this number line test is very, very, very critical. Yes. Huh? No, because that's f prime of x graph. It's not f of x graph. We don't know what f of x graph unless you analyze f prime of x graph. But the minimum and maximum of the f prime of x graph is actually an inflection point rather than max and min on original function. Okay, question 15. Question 15, I'm going to erase this. This is actually a good question. I never seen this question until this worksheet. I thought it's kind of cool because the person actually drew it on his own, and that's actually pretty cool. It may have a question like this before, but this one is going to be f of 2 is equal to 0 because it's crossing x-axis. Now this one's f of x graph. F double prime of 2, f prime of 2 is negative. Is that okay? Because it's decreasing, right? Now f double prime of 2. Now you can probably argue this is a kind of like inflection point, but it's not true because the inflection point occurred already here. So this one's concave down and this one's concave up here. So everything on right of 3/2 is actually positive. So f double prime 2, this is the correct answer, B. Does everybody understand everything? How much time have?
3 minutes.
2 minutes. I can explain it, but I have a headache. I can explain something in 2 minutes. You want me to do it?
No.
No? Huh?
5. Number 5.
Number 5, I'm gonna hold off to. I think like there's still something like the wording. I just kind of confused me. Like when it at least exactly too distinct. So let's go. Let's see. Number 5. What?
Why
I don't want to experiment. I think my head is too much in pain for it. Okay, homework to finish the last two questions, okay? It's FRQ. You had to justify. Huh? My brain's not working for fun. I'm gonna be honest to tell you, like, I was so confused. My brain's like,
We're trying to make it fast. Very much, I'm gonna go and throw a bunch of
yeah.
You want me to pass it for your assignment? Yeah, we gotta read that also.
Well,